This is called a piecewise defined function. It is defined as f of x equal to, and then we have two parts that the x-axis has been broken into, and that is where x is less than 3 and where x is greater than or equal to 3. So this definition tells us to break the graph into two parts. Now this graph below shows us that this graph would be separated to the left of this dotted red line where x will be less than 3, and then to the right where x would be greater than 3. So if I was to find values of the function for differing values of x, like for instance, if I found f of minus 2, well, I would note that negative 2 is less than 3. So according to this definition of the function value would be 1. Whenever x is less than 3, the function value is 1. So f of 0 would be 1. F of 1 would be 1. Because all of these x values, negative 2, 0, and 1, are less than 3. And we're told that if x is less than 3, the function value is 1. So this would happen all the way up to, but not including, where x is equal to 3. If I was to find the value of the function x where x is, or the value of the function f where x is equal to 3, well, when x is equal to 3 or greater than 3, the value of the function is negative 5. So f of 3 would be negative 5, as would f of 5 be negative 5, or f of 10 would be negative 5, because all of these values, 3, 5, and 10, they're all greater than 3. So the function value is negative 5 whenever x is greater than or equal to 3. So what would this look like on the graph? Well, whenever x is less than or equal to 3, or rather whenever x is less than 3, the function values are 1. So like for instance, we found that when x was negative 2, the function value, or in other words y, f of x and y are the same thing, would be 1. F of 0 would be 1. F of 1 would be 1. And as a matter of fact, anything up to where x is 3 would be 1. So this part of the graph would just be this constant horizontal line that goes off to the left like this. And then it would be similar on the other side, except that the function values are all equal to negative 5. So when x is 3, y is negative 5. When x is 5, y is negative 5. When x is 10, y is negative 5. So the rest of the graph then would look like this. Now what about to the right of this dot here, where we go up to where x is equal to 3? Well, we would have to have an open hole in the graph there so that we don't violate the definition of a function, where if we pass a vertical line through the thing, we only hit it one time. So we would have an open hole on this part of the graph and a closed-in dot on this part of the graph.